Hi everyone, back to make another video on SH5 doing a night engagement. So this would be a historical demonstration of a historical night approach. I did the day approach one a few months ago and figured to do a night one would make sense because the tactics are a little different. We're going to approach the target a little differently. We're going to follow the kind of protocols or doctrine from the U-boat commander's handbook. Approaching on what was known as the Hundekurve, which is, in German means dog's curve or pursuit course. So keeping our bow on the target to minimize our silhouette, and do so all the way up till the shot, and then turn away. So we're gonna make use of the attack disc to show how you can take advantage of the attack disc to help you set your TDC up to be able to keep your bow on target at all times. That might be one of the bigger takeaways from this video. So it's not necessarily an intuitive thing, but it's definitely helpful to know. So I've got a tanker crossing my bow here. You can see probably about 4,000 meters away or so. And so if that's hard to see in the binoculars, what I've done is I've enabled the HUD here, the filter, so you can actually see it. I usually keep that filter off because I like it to be really dark, but I've enabled the filter here just so you can see that. Hopefully you can see that ship a little better. So the first things first, what I'm going to do is we're going to do our standard Ausdampfen procedure to match course and speed. I'll demonstrate that. It's going to be very important. This is the same type of thing that I demonstrated in my day engagement video. So if you want to see that, how that's done during the day, you can watch the day approach video for SH5 on my channel. But suffice it to say, we're gonna just start by matching this. So the first step, of course, is we want to estimate its course. And what we do, the way we do that, at night is, since we can see the angle on bow, because we can see the entire superstructure and hull of the ship, we can simply just eyeball the AOB and go from there. So you can see the bearing is now about 7 degrees or so. So we'll go to the attack disc, slave it to our course. We take the bearing pointer here and we align it with 7 degrees down here, and then we turn the target disc until let's say about I would say maybe 70-ish, 70 right or so. So maybe we're looking at a course maybe of like 116, so we'll turn to 116. Okay, so the first step is we just eyeball the AOB, and we want to now, once we eyeball the AOB, then I use the attack disc to figure out what I think the course is, and then to start performing our Ausdampfen, our matching, we want to turn parallel. Okay. And so while we do that, I'll go in the map, and this is also something I demonstrated in my day approach video. But go in the map and going to just put a line that's going to be, let's just make it 10 for now, and then we're going to make it a course of 116. 116. Yeah. Right. So that's going to be the vector that we use. We're going to adjust it once we get a match on its speed, or we think we have a match on its speed. We'll adjust the length of it to correspond to our speed. But this will be what we the course that we think they're going. Okay. So, all right. So we're turning now. Let's just see what our rudder situation is. Okay, good. So we are all set there. Okay. So so the next step here is to watch the bearing drift. Okay. And we're gonna just sit there and watch the bearing drift, and I can already see it's moving backwards. So I'm gonna bump my speed maybe down to 10 knots. See where that goes from there. the one thing you can do is, and I demonstrate this in my day approach video, but just watching to see if the range opens or closes at all. Because if you're steering a parallel course, again, like I explained there, not only should the bearing not change, but the range to the target should also not change. And we don't really care about what the actual range is. We care about whether, you know, it's growing or shrinking in our optics. Okay, and the way we can do that is, I have the stock TWOS optics enabled. Well, not enabled, but I just don't have any other optics mods enabled at the moment. So what I've got is just a simple binocular view without any marks in it. But if you use like EMPGUF's optics, you have actual historical gradical markings in the binoculars that help you with this procedure. I would like to find the only problem with his mod, with his optics, then, is you lose the 8 magnification in the binoculars. It's actually weaker than the UZO, and in reality it was actually 8 versus 7. The UZO had 7 and the Skipper's binoculars had 8. I like having more powerful binoculars than the UZO, but that's just not the case with his optics. So I lose out on the gradical, but I get higher optics, higher magnification. It is what it is, okay? So, but you can see he's there, okay? But there's really no way for me to tell how large he is in this because I don't have those markings. So what I suggest you do, if you're just using stock or the basic TWOS optics, is you can simply, once you get to the point where the bearing stops changing, so that'll be our first step, you can just use reference points in the UZO, like you can see I'm lining the center line up with the bow wake, okay? And then watch, like you can see the stern is like at the 7 right there. You see that? And so that's a good way to orient yourself on how long he's appearing. Use the length, or you know, if you want to use the height, you can use the height too, but it's just hard because of the destabilization that I have here. Okay, so the bearing is clearly moving backwards at 10 knots, so I need to bump my speed down. I'll just maybe bump it down to 8 and see where we go from there. And then all the while I'm going to watch and see if watch the bow wake and the stern wake to see if the target is getting longer or shorter. That way I know that I need to adjust my course a little bit. Okay, so you can see the stern wake is just inside of the 7 here. So we're gonna just look at that and see what we need to do. Okay, that's gonna tell us if we're on a parallel course or not, because so this is looking a little better right now at 9. We're still on 115, so we'll keep a watch on to see if we need to adjust our course at all, if he's getting further or closer away, if it's obvious. So we're going to watch that stern wake and see if that stern starts jutting into the 7 there, and I know he's getting longer. Okay. Yeah, so that bearing is actually pretty steady there at 9. Pretty steady at 9, actually. Let me, let's call it 9 there. We'll try to get it to be exactly at 9. It might be good. And then we got that right on the bow wake there, you can see. Okay. Alright, and he actually is getting closer. I can see that the stern is now jutting into the 7 more. So we're just going to change course by about 10 degrees. And we'll go to 125. And when we do that, we might need to adjust our speed again to keep the bearing constant. What we're doing by changing course away is trying to get it so that he doesn't get any closer. Right? We want to be able to match course and speed. We should already be pretty close, just because we were able to eyeball the angle on bow when we first started. But this allows you to refine it some more. Right. Okay, so you can see there. Right on the bow wake there. Just gonna watch to see what the bearing does. You can see, like, right, the stern is right aligned with the 7 right now, so we'll keep an eye on that as well. So we're pretty steady at 9 knots now. We're gonna just watch that bow and see if the bearing moves forward or backwards. It's actually staying pretty spot on right there. And here's a little hint too. If you get to the point where, in a situation like this, where you're dialed in pretty much close to a round knot figure, like let's say like we're pretty close to 9 knots here. Okay, if that's the case, and you have only just a very slight bearing drift, just change course to suppress it. Don't sit here. My point is, don't sit here and think, oh, I need to go like 0.2 knots higher or lower or whatever. No, just assume. I would say go by the half knot. You know, if it's 9 knots on the dot and the bearing is moving ever so slightly, just adjust course to get the bearing to stop moving. Or if it's like, 9.5 and it's right on 9.5, just adjust course to suppress the bearing change. My point being that, ships are going to be traveling probably on the knot or maybe on the half knot. Or in other words, you don't have to have that kind of granular exactness to this exercise. You could just simply say, okay, 9 knots is sufficient, or 9.5, and any course difference, because of you changing course a little bit, isn't going to make any difference at all. So we're spot on 9 knots right now, and we're going to watch. We're going to watch to see what the bearing does. Now we're also going to see what our length is doing. So remember we were right on the 7 before, and so we can say, okay, so now you can see that I can see that if anything, it's gotten a little further away. And we'll see what we do at 9 knots here. Yeah, yeah, so he's pretty steady there. Now he's gaining on us a little bit, actually. So if he's gaining on us, and we want to keep it at 9 knots, right? Because we're at either a full knot figure or a half a knot figure, right? We're at 9 knots, or if we're at 9.5, we would keep it at 9.5. But we're at 9 knots, okay? And the bearing is moving forward, so we need to actually turn to port, because we need to put in more on our beam to suppress the bearing change. So what we're gonna do is we're gonna go to let's just go to 120. See what that does for us. And by turning toward him a little bit, by putting him closer to our 270, that's gonna help us prevent him from going any more forward. Okay, and that probably should be close to what we need. So we're gonna check your rudder, centered, okay, and then we're gonna put the crosshairs right on the bow again, and watch our reference points. Now we're lucky because this target is not changing course, okay, but sometimes in this, certainly in TWOS with SH5, I mean, the targets will change course, can change course throughout the course of the engagement, and so you might, in a pinch, just have to simply match what you think the course is, and then just match the speed quickly, and then go from there. Right? You might not have the opportunity to do a longer procedure like this, okay? But So you can see that is pretty spot on. That bearing is really not moving at all. So I think we can conclude that the course is like 120 or 121, okay, and the speed is 9 knots. We're going to go with that, okay? You can see that nothing is changing here. It's pretty much spot on. So what we do is we go to the map and we're going to do our triangle again, just like I showed in the other video. So the course is 121, and our speed is 9 knots. So 121 at 9 knots. We're going to use 9,000 meters as a proxy for 9 knots, okay? And there's 121 right there, okay? All right, and then the bearing, we were parallel course. So the bearing is actually 247.5. So we'll go to the attack disc, and we'll go. What was the true bearing? So the relative bearing was 247.5, which means the true bearing was like 188.5. Excuse me, no, 7 point or 8.5. 8.5. Okay, so we go to here and we do 8.5. We're gonna just draw. We're gonna draw 8.5. And that is right about there. Alright, and then we're gonna just draw a line that goes like this, just because we might have to adjust it on the other side of this course line here. Okay, so to reiterate what I've done here, this is our speed vector, okay? This is the bearing, right? If it turns out that the course is wrong, which I don't think it is, but if it was wrong, okay, the target wouldn't be going 9 knots. The target would be going, like, let's say the course was actually like 130, okay, 130. The speed is now 9.8 knots. You see that right there? Right there. You see the length of that would be 9.8 instead of 9, because we think we were on a parallel course and we had matched it's got a constant bearing. Our speed vector and course would be the same as the target's, no difference. But if there's a difference, let's say here we're going 130 and we realize that relatively late, we would come back to this triangle and draw one, a 130 like this to the end of our vector, and then read the speed off. It would be 9.8, just like that, okay? So that's we might have to do that, and it might be, the speed might be, or the course might be 110, and if it was 110, well, then the speed would be like 8.5 knots. You can see that right there. So you can see this is why we do this, because if we have to adjust it at all, we're going to get a different speed answer, right? But I don't think we will. So, okay, so that's that. We've got the course and speed. We think it's about 120, 121 in terms of course. Speed is 9 knots. Okay, so I'm just going to have the XO put the speed we want into the TDC. There we go. That's in. Okay. The next step, we're going to accelerate. I'm just going to go, in the interest of time, just going to go to flank speed, and we're not going to get in front of him all the way. What we're going to do is we're going to get in front of him to about an AOB of about 30 or so, and then we're going to turn in, and we are going to approach on the dog's course, so keeping our bow on the target all the time, all the way up until the point we shoot. And then at that point, as soon as we shoot, we'll turn away and watch to see the results. Okay, the benefit of that, of course, is that you keep your bow on by keeping your bow on the target all the time is A, you reduce your silhouette, and B, you know that you're going to have a relatively low gyro angle. The torpedo's going to have to turn a little bit just because you're not leading the target with your boat. You're pointing directly at the target, but so you're going to have somewhat of a workable range estimate, but it won't, the range being off by much won't matter too much. Okay, so it's more important that you're keeping that bow directly on the target so that you're not running the risk of getting spotted. Okay, so I'll go ahead and set my torpedoes up now. I got a G7A there. I'll go ahead and flood the tube. Let's go ahead and put our guys on battle stations. We're going to have the depth set to 4 meters here, and then keep it at impact, and then let's go fast. We should be good there. Alright. Okay, so we're going to go. Now, the one thing we want to do to monitor the AOB, to use the attack disc again, is we always want to, if we have this switch selected here, it will automatically slave the attack disc to our course. Okay, that'll be across from the white triangle here. Then all we need to do is simply keep the target disc pointed to the target's course, which in this case is our course. So we'll line it with 121 there, and then we're always updating the bearing. So now the bearing is going to be 240. So we'll simply come here and then put the bearing on 240 here. You can see now the AOB would be 60 degrees. Okay, so we're always monitoring that. We want the AOB to be 30 degrees. So what we're going to do is we are going to put this to 30 right here. You can see that, and read the bearing off. Bearing, if we were to stay on this course, the relative bearing would be 211. 211. Okay, we might not stay on this course, so we might just turn in a little bit to keep the video moving. So I'm gonna just come in by about 10 degrees. We're gonna use some time compression to get ahead here. Okay, so we're slowly getting in front. I'm actually gonna go full speed a little bit there. Drop my speed down a little bit. So now that we've changed course, we need to update the target disc to be the target course again, 121, and then we read off. We set it to the bearing, which is 231 or so. So we then move this to 231, and we read the angle on bow off. It's like 41. Okay, so we're always watching and comparing the AOB with what we see, with the answer here. 41 with what we see, and we can see, yeah, that looks about right. It looks about 40, 41 or so. All right, so I'm gonna just turn another 4,000. Okay, I'm gonna turn another 10 degrees in, and then update the attack disc again to its course of 121. Okay, and then at this course we're going to see what the bearing we need it to be to get 30. Okay, so you can see I'm aligning with 30, and I'm reading off the bearing, the relative bearing, at about 230. Bearing of 230 is when we're going to turn in. So you can see there's the bearing there, 235. We're just going to put it on 230 here, and that's the bearing we know we're going to turn in at. Okay, right there. Getting there, getting there, getting there, getting there. Okay, right now we can, what I'm going to do is go half speed ahead, and I'm going to start turning in. So we're going to turn to right about there. Alright, I just did heading to view, and now we're turning in for the attack. What I'm going to do once I'm on this course is I'm going to set my speed to maybe like 5 knots or so. I want my speed to be under 7 knots. I don't want my speed to be any higher than 7. I would like to think that it's modeled in the game. I know in SH3, like a modded SH3, you needed to watch your speed around the targets at night, and the reason for that is because of your bow wake. Okay, your bow wake can glow at night. It can become phosphorescent at night, especially with higher speeds, and so you need to go slowly to make sure you keep your bow wake down. Okay, so we're gonna do that. Once we get on course here, we're gonna get down to be about let's just say like maybe 5 knots. We'll approach the target at 5 knots. Alright, so let's check the rudder here. Rudder's coming up. Switch to the UZO here. Let's see what we got. Okay, so we need to, and now we're going to be making, pretty liberal use of the rudder here at this point. Because our goal at this point is to keep that target on 0. Alright, so we're always going to be keeping that target pretty much on a 0 bearing. Okay, and let's go ahead and set under the rudder now. Let him sail into our 0. And I'm going to put our speed down to about 5 knots, or even less than that. Let's go to 4 knots. We're just going to creep our way at him. Okay, so he's coming now, you can see. Once he comes, once he gets to about center there, we're going to put some rudder in. So we can start putting some rudder in now. Okay, and then we're going to turn with him like this as we approach, and that's even too much rudder, you can see. So you just keep that center line on the target. That way you know your bow is always on the target at all times. And then what we're going to do is we're going to, so now that we've got it on 0 and we've got the target on 0, when we come to the attack disc, first step is we set the bearing to 0, and it's not going to move from 0. For the rest of the evolution here, it's not going to move from 0. It's going to stay locked on there because we're going to keep the target on 0 the entire time for the rest of the approach. So there it is, 0. Okay. Now all we're going to end up moving is the target disc. So you can see the target disc, and we're going to get it at 121. Okay. And in increments of 5-degree AOBs, we're going to have our first watch officer update the AOB in the computer. Okay. Why I'm going to have them do that is because if I need to shoot for whatever reason, I want it to be always updated. Because I don't want, oops, we need to keep on the target here. Because I want to keep the AOB updated in the computer at all times. Because if something happens, if this were a convoy engagement, something happens, and I think I'm going to get spotted or whatever, and I want to shoot now, I don't want to have to fuss with it. Okay. Alright, so there we go. So play with the rudder, keep your bow exactly on the target. We don't have to worry about the bearing. We're going to update the AOB like this, or update the target course like this, and I'm going to set to 35. You see that right there. Alright, so go ahead and update angle on bow to be 35 right. Okay, and then we know now and then the range, keep it at 3,000 for now. We can always update the range like this, 2100. He's saying it's probably a little, that might be okay. Keep the range updated as well. This is sort of like your watch officer is at the UZO calling down to the TDC guy his updates to his estimates. Okay, that's what this is simulating. It's keeping the computer refreshed with fresh data all the time. Okay, so you can see now we're gonna update the AOB again. So here we go, 121. Now we're approaching 40. So we come over here, say, all right, let's give me 40. Okay, that computer's updated now. Now if we were to pull the trigger, we know that we would have good data in the computer. Now what we're going to be monitoring here is we're going to be monitoring the track angle. So when we know we're going to fire is when the track angle is getting close to 90. Okay, so you can see there's kind of a few different things at play here. We're keeping our bow on the target, but then we're monitoring the AOB with the attack disc, and we're monitoring the track angle with the track angle dial here. Okay, and we're also going to monitor the range just so that we know that the range is going to be good for if we have to immediately shoot. Alright, so then we need to increase our rudder a little bit to keep on the target. Let's take a look at the course. Course is 121. We're approaching 45 degrees, so let's update the computer to 45 degrees. Okay, there we go. Now in real life, depending on the TDC model, of course, in the later TDC models, 1941 forward, You wouldn't have to do that. They'd have a setting on there that would automatically take your course changes into account so that you're always seeing the computer is giving the correct AOB regardless of what your boat is doing, but that's not the case with SH5. Okay, so there we go. So you can see we're getting closer. The track angle is slowly increasing, which is good. We are still keeping our bow on the target, which is what we want. We're maintaining our stealth here by doing that, and so that's good. So then again, we're going to update to 121. Now we're at a little over 50. Okay, so we're going to set this to 50. Keep the computer updated. There we go. 50 still looks about right. Pretty soon it's going to be 55, so I'll do that. Okay, keeping everything refreshed. Okay, range is going to be now less than 2,000. Right, he's saying 1,800. That's probably good enough for me, I guess. Okay. And the reason why we need a range setting here is because we do have a little bit of parallax error because we've got a gyro angle that's not 0, so the torpedo needs to turn a little bit, so it's good to have a range estimate in the computer. If we were just shooting a straight torpedo, range wouldn't even matter at all. Okay, so we're going to turn more. Now you can see we're within 60. We're getting into a good area now in the track angle where we are at. Yep. Okay. Yeah, we just need to increase the rudder angle there. Okay, so let's go ahead and increase the. Let's update to 121. Now we've got 65 in, so we can boom, boom. So now you can see it's even better. So that's good. So now we're close. We're getting pretty close to 90 here. We can probably shoot pretty quickly here. I'll go ahead and update the. So here's what we want to do now. This is where it can get a little tricky, but you need to pay attention. So we're gonna pick an AOB we want to shoot at. We're gonna let the AOB grow another 5 degrees and shoot. Well, what I mean by that is we're gonna let it. Let's get to one. Once the AOB gets to 75, we're gonna shoot. So let's go ahead and preset the computer. 75, good. So now we're gonna watch. Okay, now it's getting there quickly. So now we're there already. So we need to shoot. All right, here we go. Now that we've shot, half speed ahead, turn away immediately. I've got hard to port. Okay, the range, I didn't update the range, but it shouldn't be that far off. Okay. So now what I did there is while I was, yeah, the range is actually going to be much less than 1,800. So we're the hit's going to be a little off center, but that's okay. Should still be fine. But just to reiterate there, what I did was, since we were turning, I needed to pick an AOB that we were going to hit, and I updated the course on here. And there it is. Okay. There it is. Okay. Yep. Perfect. Okay. Oh yeah, it wasn't too far off center. The difference was because of the range. I didn't update the range. Should have been much less. Okay, but let's go ahead and center the rudder. So to reiterate what I did there, I'll do it on a mock target here. So I said, okay, I had bearing at 0. Okay, and let's say the course is 60. Okay, 60 degrees. Let's say this is a mock target here. Okay, the target's straight ahead, bearing is, course is 60 degrees, AOB is 65. All right, I'm turning with the target. I've got, let's say, 5 degrees of rudder set. Okay, and I say, what do I want to shoot at? Okay, so he's got 60. Let's say, okay, the track angle is going to be really good once the AOB reaches 75. Okay, so you can see as we turn, I'm always keeping the 60 on the pointer on 60, and I'm going to preset the TDC to be 75, which is about right there. Okay, and I'm going to turn right there, and I'm going to watch and say, as I'm turning, it's getting close to 75. Okay, right there, boom, I would come back, make sure I was still on target, and shoot. And then I would immediately turn toward the target's stern. That way I know I'm out of any danger zone and not going to get run over, whatever the case might be there, okay? So that's what I did there. That's how you can actually keep your bow on target and set the TDC up that we have in the Silent Hunter series, which works a little differently than real life. That's how you can make that happen effectively. Keep the bow straight on target at all times, and basically preset the AOB on the computer, and then wait until you use the attack disc. Just always keep the course updated on here, and then watch how the AOB changes. And as soon as the AOB gets to what you preset, you shoot and turn away. Okay, that's how you would do basically a night approach with using kind of the historical doctrine, historical techniques for that. Okay, so so that covers matching. Again, that's a reiteration. Do Ausdampfen every time. It gets you very, very accurate results without having to look in the recognition manual, without having to use, a stadimeter or whatever, other tools you might want to use. Just simply match course and speed. It's very straightforward. Draw your simple lines here. Know that, if you say, oh, the course was wrong, and then just, then you draw the new course in down to the end of your speed vector and read the speed off. Okay, that's that's all. That's as easy as it gets right there. As you can say, okay, the course is really 130. Oh, I guess the speed was 9.7 knots, and then you can quickly update it in the computer. Okay, that's much easier than flipping through the recognition manual and figuring out what the target is, and then trying to do measurements at the last minute before shooting. That's not what they did, and that's not what you need to do either. Simply use these historical methods, and you can be very successful, and know that you're not relying on anything in the game. You're simply just doing what the target is doing, and just using your eyes to observe and use that to get your data. Okay, so that's how a historical night approach would look. Obviously, things to consider with it are, well, in terms of gameplay, really the only thing to consider is, attack from the dark side. Keep the track of the moon, which you see right here. Keep the target in that, or I should say, approach from the dark side of the target, so that the moon is in front of you, so that you are not on the moon side and getting caught up in the track of the moon like this. Okay, that's what you want to pay attention to, where the dark side of the target is, and approach always from that side. Historically, you'd have a consideration of which direction are the seas going, waves moving. Obviously, it's better to attack with the sea versus against the sea. The big reason there is because you're going to make less of a bow wake, for one, if you're going with the sea, and then also the target is going to be having a hard time looking upwind for you. So approaching from the windward side, as they call it, has the advantages of you kind of less bow spray, and then you're also going to have the enemy is going to have a harder time watching for you, because they're going to have to be looking upwind. Okay, so those are considerations if you want to simulate that, but certainly the moon aspect is something you should pay attention to in the game. So anyway, that's the night approach. Much shorter, sort of short and sweet, quick matching approach. Keeping your bow on the target is the biggest takeaway, and then how to make that happen with the attack disc. All right, so if you have any questions, of course, let me know in the comments. As always, appreciate it. Take care.